we're going to look at integration or differentiation with logs. Now, remember this. Remember that last time we said if you want the derivative of a log, it's just going to be 1 over x, like that. So that's pretty easy. Now, we could apply the chain rule. We could say, well, I want the log of something like, let's say 3x plus 1. Something like that. Well, remember the chain rule. You've got 1 over 3x plus 1 times the derivative of 3x plus 1 is 3. So this would be 3 over 3x plus 1. So now we're differentiating, and we're just using this idea, okay? And we're saying, okay, there's the derivative of the natural log, but sometimes we have to apply the chain rule. The chain rule is present there. Now, let's suppose that we've got a little bit different looking problem, or a little bit more complex problem. Let's suppose that we want the natural log of the square root of something like x plus 5. Well, we proceed the exact same way. We could say this. We could say this is 1 over the square root of x plus 5, but then we have to apply the chain rule. And the chain rule says to multiply by the derivative of the square root of x plus 5. So that's going to be 1/2 x plus 5 to the negative 1/2. Okay? That's what we have, right? Because x plus 5 square root is x plus 5 to the 1/2. And then we have this. And of course, I guess that's really just going to be 1 over 2x plus 5. Right? Because the square root drops down, and then you've got the square root times the square root. So it looks like this is the answer. It looks like that's the derivative. Now, I realize a lot of you have seen this in your previous calculus class, so I kind of went through this fast. Remember, we're going to practice here in just a minute, but the idea is we're using the derivative of the natural log, what we know it is, and then just applying the chain rule. But with logs, we've got some tricks up our sleeves to make things a little bit easier. For example, this problem right here, I could remember these properties. Remember that if we've got the log, and let me just use, I'll just use natural log here. If we've got the natural log, whoops. Okay, let's suppose I've got the natural log of u times v. Remember, we can write that as the natural log of u plus the natural log of v. So that's one of the properties of logs that we might be able to use in differentiation to make things easier. Now we've got log of u over v. That's going to be log of u minus log v, like that. And then the other property we'll use a lot is u to the r, let's say. Okay? Or we can bring the r out front. Okay? So maybe we can make use of those properties to make some of the differentiation easier. So, for example, this problem here. Notice I want the derivative of the natural log of x plus 5 to the 1/2. That's what I want. Well, because that's a log, I can write that this way. The derivative of 1/2 log, log x plus 5. Okay. Yeah, you can. You can bring it all the way out front. Remember, if you have a constant, you can factor the constant outside before the derivative, right? So, in other words, the derivative of a constant times a function is the same as the constant times the derivative of the function. So I could just write this as 1/2 times the derivative of the log of x plus 5. And the log of x plus 5, the derivative of that is 1 over x plus 5. So we have 1 over x plus 5. And you notice that's what we had here. It's exactly the same. So there we're able to use properties of logs to get us to the derivative. Now, this is maybe not so big of a deal with that problem because that problem wasn't very difficult. But maybe we have one that's more difficult. Like, for example, let's suppose that we have x squared, x plus 2 to the third over the square root of x plus 1, something like that. That one is a little more complicated because if we don't use properties of logs, what we're going to need to do is we're going to need to say, okay, 1 over this stuff times the derivative of this stuff, right? And the derivative of this stuff involves the the quotient rule and the product rule. Okay, so now I left off the log there, I noticed. Okay, so let me do this. Okay, the log of that. Okay. So here's what we want to do. Before I differentiate, I might want to break this bad boy down a little bit and say, okay, this is going to be the log of x squared, x plus 2 cubed, okay, that, minus the log of x plus 1 to the 1/2. Okay? So far, all I've done is I've just used that property of quotients, right? Just subtracted off that thing. Now, let's see what more I can do. I can say, well, that's going to be the same as the derivative of, let's see here, the log of x squared plus the log of x plus 2 cubed, okay, minus 1/2 log x plus 1. Okay? Things good so far? Okay. Now we can go further because notice on this one I brought the exponent out front. I can do the same thing here. I can say, okay, let's see what we've got. 2 log x plus 3 log x plus 2 minus 1/2 log x plus 1. Now, all of a sudden, that integral that looks so intimidating, once we applied the properties of logs to it, now it's just an infant could do this log, right? I mean, an infant could differentiate this. So look what happens. The derivative of this is just going to be 2 over x. The derivative of this is going to be 3 over x plus 2. The derivative of this, negative 1/2, 1 over x plus 1. That's the derivative. And you're done. That's it. Now, you can always, find a common denominator and combine everything. But if you don't use properties of logs like this, you're going to have a bad time. Right? So you need to use the properties of logs. And that's going to help you. Any questions about that?